Hello, my name is Tigmanshu Bhatnagar, and in this workshop video, allow me to introduce you to Tacilia. There are a growing number of refreshable tactile display devices that are in the market today, and these display devices use a number of different technologies. However, the cost of these devices is prohibitively expensive. Now, to address this challenge, we explored Tacilia. Tacilia is a semi-permanent, refreshable tactile display made from just a single sheet of nitinol. The working principle of Tacilia is based on the shape memory effect of the material, where we need to heat individual pixels to actuate them that can be mechanically reconfigured. To make Tacilia, we first need to laser cut U-shaped cantilever beam pixels on a thin sheet of nitinol. The design of these pixels needs to consider that the maximum strain on bending remains below the maximum recoverable strain of the material. Now, to program these pixels, we first need to constrain them to the bent position at room temperature and then keep this fixture at a furnace at 500 degrees Celsius for 30 minutes and quench it in a water bath. This would train the material to memorize its new bent position, but the pixels would remain stiff, and hence we need to anneal it in order to make it reconfigurable by keeping it in the furnace again for 2 days, after which the pixels can be mechanically reconfigured, but they snap back out flat state and retain that even when they're cooled. So we get a maximum out of plane displacement of around 0.4 millimeters with a blocked force when the sheet is at room temperature of around 0.23 kilograms, which is sufficient for tactile interactions. The temperature to fully actuate the pixels is around 49 degrees Celsius, but at 3.6 degrees Celsius per second cooling rate at ambient temperature, the sheet is comfortable for direct interaction in a second, and it also takes a second for the pixels to actuate. All of this work has been previously published at the World Haptic Conference. Different pixels designs can be explored using this process, such as an overlapping V-shaped pixel that increases the length of each pixel so that a larger out-of-plane displacement can be achieved. We observed no fatigue failure up to 2000 cycles. However, we observed a two-way shape memory effect emerging in the material. You can think of Tacilia to be some form of an e-ink display of the tactile display world that retains either its bent position or its flat position until it is externally heated or mechanically reconfigured. A few limitations, such as the slow refresh rate of the material, but reading tactile media on a large surface may not require rapid refresh rate for a number of applications. We continue to explore those applications so that people with visual impairments have access to an affordable yet refreshable tactile interface.